Okay, this lesson is A8. It's classifying numbers, and we're going to classify numbers as either rational, irrational, natural, whole, or integer. So we're going to first start by explaining what a rational number is. And again, if you've printed your note sheets, you're going to want to fill in all of these blanks as we go. A rational number is any number that you can write in the form A over B. So a rational number can be written as a fraction. It doesn't have to be a fraction, but it can be written as a fraction. For example, the number 5. 5 can be written as 5 over 1. So that would make it a rational number, because I can write it in this form. B cannot equal 0. The reason B cannot equal 0 is because you can never have 0 in the denominator of a fraction. That's undefined. Division by 0 is undefined. We'll get to that in a later lesson, but just to refresh, we can't have B or 0 in the denominator. Okay, a rational number that's written in decimal form is either a terminating, which means ending. Terminating means ending. So it's either a terminating decimal, such as 3.65. Notice it ends. There's nothing else to the right of it. Or it can be a repeating decimal, such as 2.414141, and the 3 dots here tell us that that goes on forever. So rational numbers can be written in this form as a fraction. They could be a decimal, because you can write these decimals in the form of a fraction. Okay, the next 3 number sets we're going to talk about are all subsets of rational numbers. If a number falls into one of these categories, it's also a rational number. That's why it's called a subset of rational numbers. The first one are natural numbers. Some people call those counting numbers to help you remember what are the numbers you use to count with. When you start counting objects, you don't start with 0. You start counting with 1. So 1, 2, 3, 4, 5. Those are all counting numbers. Notice they don't include the numbers in between 1 and 2 or 2 and 3. No decimals or fractions in between. It's 1, 2, 3, 4, 5 to infinity, going on forever. The second one are the whole numbers. Whole numbers look very similar to natural numbers, but notice they include 0. So whole numbers are the natural numbers and 0. So 0, 1, 2, 3, and go on forever. Again, there's no numbers, decimal numbers in between. It's just the whole numbers. And then the third subset are the integers. Integers are the whole numbers. They're the natural numbers, but they also include the negative numbers. So this goes on forever in the negative direction as well as the positive direction. Okay? These are all types of rational numbers. Remember, they're all subsets. So if you have a number that's an integer, it's also a rational number. That is opposed to irrational numbers. An irrational number cannot be written as a fraction. Cannot be written in fraction form. If a number is given to you as a decimal, the way to decide if it's irrational, you have to see if it ends. If it does not ever end and it doesn't repeat, then it's irrational. Okay? Remember, if you look back up at the rational notes, a rational number does end or repeat. Irrational does not end or repeat. So let's look at the numbers we have here, and we're going to decide where they fall into our classifications. Are they rational, natural, whole, integer, or irrational? And some will be more than one. For example, the number 24. 24, look at your number sets, is a natural number. It is a whole number. It is an integer. And it is a rational number. So we've got to fill all of those in next to the 24. Okay, so it's a natural number. It's a whole number. It's an integer. And it's rational. Negative 5. Well, negative 5 can't be a natural number because you wouldn't count using a negative. Negative 5 is also not a whole number because they don't include the negatives, but it is an integer. And it's also rational. Sorry, that's hard to read. That says rational. Doesn't look like it, but that's what I meant right there. All right, 2.345. Now we have a decimal. Look at our decimal rules. If it does not end and it doesn't repeat, it's irrational. Well, look at this. This ends. It doesn't repeat, but it does terminate. So since it does terminate, that makes it a rational number. A little bigger there. There we go. Okay? It's not a natural, a whole number, or an integer because it's a decimal. Number 4, look at this long decimal. The 3 dots tells me that it goes on forever. It does not end. So now I have to check to see, does it repeat? I'm looking for a pattern here. There's no repeating pattern. So since it doesn't end and it does not repeat, that makes it irrational. Okay? 3/4. 3/4 is in the form of A over B. So this is in the form of a fraction, so that is going to be rational. Okay. Let's look at number 6. It's a decimal again, so the 2 things we need to check is, does it terminate or does it repeat? It does not terminate, it goes on forever, but notice it does repeat. So this is a repeating decimal, which sometimes can be written with a bar over the top so that you know it repeats. The 4-3 repeats, so I could write it this way. Let's make sure that bar goes all the way. Let's write that over again, that's too messy. Okay? And since it does repeat, that makes it rational. Okay? And our last one is -6/2. So I know it's in the form of a fraction, so it's definitely rational. But notice, 6/2, that can be reduced. 6/2 is the same thing as 3. So -6/2 is also, can be represented as -3. So when I look at that, I know it's rational because at the beginning it's written as a fraction. So I know that it's rational, but it's also an integer. It's also an integer because it's -3. Okay? So those are our number sets that we're going to use to classify numbers. Now you can go to section A8 and do your practice problems on IXL.